Okay, so today will be the last lecture on unit number 1. We'll finish it off today. It's very small unit, not much of the things been taken to it, like introduction to artificial intelligence, then scope and limitations and approaches of AI, and then we have these intelligent agents. So once you understand intelligent agent, this unit is over. Not much of the things in this. So we have already started types of intelligent agent. So we have seen that simple reflexive or reactive type of intelligent agent is there. Then a model based agent is there, goal based agent is there, utility based agent is there, and then we have a learning agent. So these are different types of agents which we have already seen in the last lecture. So in this, the first one is the reactive agent. So we have seen the reactive agent as one of the software agents, that is a type of software agents that carry out the simple task, right? So they do not actually maintain the internal state. That is what the difference between a reactive agent and deliberative agent is. So they do not have an internal state, and hence sometimes called as no internal state reactive agent. They cannot generate results as good as deliberative agent does, but the most important thing is that in place of one deliberative agent, you can use a number of reactive agents, right? And reactive agents have the limitations. They cannot just react automatically on the basis of the information they grab it from the environment. These are the things that are coming into the reactive agent. So from the figure you can see that there is an environment. The sensors will sense the input from the environment, then it will be given to the state of world, then we'll have an action decision that is based on a rule, and then the action will be taken by the actuators, which will be the in turn taken to the environment. So this is how the reactive agent looks like. Then the most important thing is that the reactive agent should have large amount of information with them so that they can reach to the satisfactory action. Then in decision making process, the reactive agents uh, has faces the difficult to take into account some of external and non-local information. Reactive agents do not actually understand the relationship between the environmental and the individual behavior. Overall, we can say that they cannot understand the overall behavior either of the agents. Then if you want to go with a more complex reactive agents, then they can remember the properties and can also store the internal models. So based on the remembered properties and stored internal models, the action can be taken. The one of the best example we have seen of reactive agent is the autonomous robots. So the robots actually goes on a straight line and it faces the obstacle. So as soon as it overcomes the obstacle, it should regain the straight path. So how it can regain the straight path? By using reactive agents. So reactive agents actually plays an important part to complete this task. That is what the applications or example of reactive agent is. Then we saw deliberative agent. Again, a software agent that is mainly based on the symbolic world and makes decision via symbolic reasoning. So you can see from the figure, there is one reactive and deliberative. So in case of reactive, you have the environment, then the sensors are there to sense the input. Then there is a processing, which is a domain knowledge. There is no internal state, and then there is a control. So through actuators, it takes the action or controls the action based on the rules back to the environment. So this is what the reactive agent is. But in case of deliberative agent, you can see that there is an environment, sensors and actuators are there, actions will be taken. But in between sensors and the control, there is an processing. And this processing is having internal states, evaluation and prediction. And also the rules are replaced by the goals. So there is a particular goal is set, which has been tried to achieve. Okay, so this is uh, uh, the functional differences between the reactive as well as deliberative agent. In deliberative agent, there are two types of attitudes. One is the informative attitude, and the next one is a pro attitude. So the informative attitude actually involves gathering of the information about the environment, and pro-attitude is nothing but guiding the actions of the agents. It maintains the internal state, which is quite a different thing what compared to the reactive agent, and predicts the effect of the actions. So a few of the differences between reactive and deliberative is that the deliberative agent cannot replan the actions quickly. Deliberative agent can reach its goal by reacting automatically based on the external environment, which the reactive agent cannot do. Then the deliberative agent is having a symbol representation, which the reactive agent does not have. It can also process the images from the of the external environment and hence enables to execute the plan. Then the most important is that the automatic planning is carried out in case of deliberative, which involves computer processing, and hence you need a very good computational resources and efficient computational resources to achieve the target in the chosen situation. So this is what the deliberative agents is about. So a few of the things also involved like intentions. So the deliberative agent intentionally is known as the intentions. The intentions drives the means and reasoning. It stimulates an attempt to execute the intentions and hence that can lead to action. That is what the thing is. एक और चीज है इसमें जो if action fails then it finds out the other way to reach to the action and it keeps on achieving the target unless and until it feels now that it's not been able to achieve. So these intentions are influenced by the beliefs also, right? So what beliefs does help? That agents belief will help you to get the available actions. So few of the things that will come into the picture if you want to explain the deliberative agent. The first one is the observing the world, updating the beliefs, deciding on intentions, determining available options, filtering the best options, and then making and executing a plan. So this is all about reactive and deliberative agent. Now we'll be going to the next one called as a goal-driven agent. Now, as we have seen in the last deliberative agent, goal is set, but in case of reactive agent, rules were set. So if goal is set, then it will try to achieve the goal by anyhow. If it is not successful in by one route, it will go by the other route. So in this way, it can achieve. Now, what is there which is specially in goal driven agent, which is not there in deliberative agent? So that we are going to see now. So looking at the figure, if you see, there is an environment, there is sensor, there is an actuator. So sensors and actuators are the part of agent. Now, what is happening is that the sensors will be given to what the world is like now. So the clear picture of world will be given. And then what it will be like if I do action A. So the world is like this. If the action A is taken, so how the world will change. Okay. And then what action I should do now. So वो changes क्या हो रहे हैं उस हिसाब से, गोल के हिसाब से आप अपना एक्शन चेंज कर रहे हो. And then it is given to the actuators for action. This is called as the goal driven agent. Understanding? So now the sensors are sensing the information, sensing the input from the environment. Then the first, it will be what the world is like now. At the right moment, what the information they have with themselves, the agents are having the information that is received from the sensors. Then it will get to know the state of that information, right? Then it will also have how the world evolves. All this information will be there. Then how the world evolves and what my actions do. All these things are correlated with what the world is like now and what it will be like if I do action A. So what is the situation first and what it will look like if I do a kind of action. I hope you are understanding. The sensors and actuators are the part of agent, which we have already seen in reactive and deliberative agent. The information is collected. This information will let you know how the world evolves, That will be background of it. What the world is like now will be the internal state that will give you the recent or the current scenario of the information. And if I take an action A, what will it look like? So based on that, what action I should do now? That is what the goal is. So this is actually the goal driven agent. Knowing something about the current state of the environment is not always enough to decide what to do. So पहले state में आप अगर देखोगे, what is the world is like now, है ना? So what the world is like now means what? It's an internal state. So is that enough to take any decision? No, it is not enough to take in the final decision. So knowing something about the current state of the environment is not enough to do any kind of action. For example, we can take at road junction, the taxi can turn left, turn right, or go straight on. The correct decision depends on where the taxi is trying to get to. So obviously, सब कुछ based है गोल के ऊपर. लेफ्ट जा रही है, राइट जा रही है, स्ट्रेट जा रही है, उससे कुछ डिपेंड नहीं करेगा, मगर करेक्ट डिसीजन इस पे डिपेंड करेगा कि वेयर द टैक्सी इज गोइंग टू गो और व्हाट इज द डेस्टिनेशन of the taxi is. So similarly is what the current state is, what the taxi turning left, turning right, or straight on, but that is not going to help. So that is not enough to take any kind of decision. So where the taxi is going or what is the destination of the taxi will help you to know what kind of decision is to be taken. So that is what the difference is about. Right? Have you got it? So knowing something about the current state is not enough. We have to do something else. The correct decision depends upon the type of goal what it want to achieve. In the other words, as well as the current state description, the agent needs some sort of a goal information that describes situation that are desirable. For example, being at the passenger's destination, the agent program can combine this with the model. Obviously, इसका पूरा मजेदार तो यही है, summary यही है कि at least we should be the agent should be able to know what is the need, some sort of information where it will help you to reach to the goal. So even if we say that the passenger destination is most important thing as far as taxi is concerned, so the agent program will combine this into the model. Right now, taxi, see, a taxi is going, it is turning left, it is turning right, it is turning, it is going to the straight, it is going straight on. Now, does this information is enough to take any kind of decision? No, it is not enough. Why? Because the taxi is not knowing where the destination is. Hence, going left or right or going in the straight on is not going to help. Hence, the passenger should first of all tell to the taxi driver that I want to go to Pandharpur, for example. So that is what the goal is. So the information about the goal is to be known to the agent. Then only it can be said to be as a goal driven agent. Clear cut एकदम. Simple है, कोई ऐसा complications नहीं है. Okay. So how it can be do, how it can do like what the world is like now, what the world will be like if my action A will be carried out, and after that, what action I should know now, or what action I should do now. That is the goal. With the help of goal is to achieve this target. So this is called as the goal driven agent. Sometimes goal based action selection is straightforward. For example, when a goal satisfaction results immediately from a single action. So sometimes depending upon the destination, the goal satisfaction can be done immediately from a single action. मुझे इधर जाना है, that's finished. I want to go, this is my destination and I want to reach there. That's it. Sometimes it will be trickier. For example, when the agent has to consider long sequences of twists and turns, in order to find a way to achieve the goal. So obviously there will be some routes which will be having lots and lots of turns and twists. So at that time it will be difficult, it will be trickier to understand how to reach the goal, or it will be difficult little bit to find the goal. Hence, so goal based selection is very, very important, because unless and until goal is been set, you cannot achieve that goal. That is what it is. So there are two ways. One is a very straightforward, which can be done by a single action. And the second could be a zigzag path. So there will be a lot of long sequences of twists and turns in order to achieve the goal. Search and planning are the subfields of AI devoted to finding action sequences that achieve the agent's goal. So in order to achieve the agent's goal, there are two important things which is based on the AI, which is nothing but which are also said to be as the subfields of AI. What are they? Search. You're going to search the destination, you're going to search the target. And planning. So what is your planning in order to achieve that goal? So what will be the agent planning out to achieve that goal? So one is searching and the other one is a planning. These are nothing but the subfields of AI, and that will be helpful in order to achieve the agent's goal. A goal-based agent in principle could reason that if the car is in front has its brake light, a goal-based agent in principle could reason that if the car in front has its brake light on, it will slow down. So now a goal-based agent will be also depending upon the actions that is been going on the internal state. So what does it mean is that if I'm going to have the brake light on, that means it is going to slow down. So you have to consider the reasons of moving towards the target by different ways. There will be different ways. So the goal based agent is obviously going to be going to take help of could reason if that car is in front has its brake light on or slowed down. Accordingly, my car will be slowed down. So to indicate or to get the indication is also very important. Given the way the world usually evolves, the only action that will achieve the goal of not hitting other cars is to break down. So obviously, what the knowledge, ये देखो इसमें इसमें ये जो दिख रहा है क्या, this is how the world evolves. वर्ल्ड इवॉल्व में उनका बेसिक इंफॉर्मेशन क्या है कि ब्रेक लगाने की वजह से मैं सामने वाले कार को हिट नहीं करूंगा. That is what the information is have. So given the way the world usually evolves, the only action that will achieve the goal of not hitting other cars is to brake. Is it right? So from where it will come? It will come from that evolve, this one, how the world evolves. The information is stored here. So when I say that what is the world, what the world is like now, the world is like that if I will not brake, I will hit the other car. Now what action I should take? I should brake. I should put the brake on. So that is the action done. Now after putting the action done, what my actions do? Again, it will go what the world looks like. Again, the next action will be done. So it will be depending upon the actions that has been taken till it reaches to the achievement of that goal. Is it okay? So a goal-based agent in principles could reason that if the car is front and has its brake light on, it will automatically slow down. And given the way the world usually evolves, the only action that will achieve the goal of not hitting other car is to brake. So this information is all about goal-driven agent. Although the goal-based agent appears less efficient, it is more flexible because the knowledge that supports his decision is represented explicitly and can be modified. So obviously it is little bit of less efficient, but it is flexible because of support to the decision making, which could be modified. है ना? एक decision लिया, okay, based on that I have taken this one. Again, the status of that is checked and again the decision is taken. So you can modify depending upon what will happen if this action is to be done. If this action is done, what will be the next step? So depending upon that, you can represent the decisions explicitly and that can be modified. So this is a very good thing about the goal driven is that it is flexible, but it is not as that efficient as it looks like. If it starts to rain, the agent can update its knowledge of how effectively its brake will operate. This will automatically cause all of the relevant behaviors to be altered to suit the new condition. जब बारिश नहीं थी तब ब्रेक लगाया, एक्शन लिया, उस हिसाब से डिसीजन लिया, बराबर. अब अगर बारिश आ गई है तो क्या? If there is a rain, that means the update has to be acknowledgement. Now the brake will operate, but the automatic case of the relevant behavior can be altered to suit the new conditions because the condition is now rain is coming. So accordingly, my brake will be on. So the relevant behaviors have been altered. Now it is according to the rain. Earlier it was when no rain was present. So depending upon the things, the whole scenario will keep on changing. So it should be flexible to adapt to the things that has been happening around. Okay, the goal-based agent's behavior can easily be changed to go to a different destination simply by specifying that destination as a goal. So it could be easily changed. है ना, जा रहे हम लोग, we are going to Pandharpur and suddenly I decided to go to Mangalveda. Now the destination will be changed. So accordingly, the decisions will be changed. So different destinations can be easily changed by specifying that destination as a goal. So it could be changed. The flexibility is very good in case of goal-driven agent, but it is a little bit less efficient as compared to the other agents. This is all about goal-driven agent. So I hope you have understood. Once again, I'll just, so you can see here, this is the main diagram that will be useful. Sensor senses the inputs from the environment. It will be given what the world is look like now. So all the information will be stored here. This is nothing but the internal state. The state will keep on changing up according to the action taken. Now what my actions do at this moment is there, and what the world evolves is also there. So all three is coming here. Now the action is taken. So what it will be like if I do action A. So accordingly, with the help of how the world evolves like and what my actions do, the actions will be taken. What will happen if my action A will be taken, and according to what action I should do now based on the goal will be considered and converted into the action taken. That is what the goal driven agent does. Now the next one is a utility driven agent. So utility driven agent is, again, you can see the two figures of the earlier of the deliberative agent and a goal driven agent, and then we are moving to the utility driven. The changes are happening in this block. Now if you look at the goal based driven agent and utility based driven agent, then you can find out the difference here easily. So here you can see sensors and actuators are very common thing in agent. They are the common part. The environment will be also there on which it will be taking in and taking out. So now what the world is like now is similar to what there in goal driven agent was there. So how the world evolves, the internal state, all this thing is same. Now what it will be like if I do an action A will be also similar. Now only the thing is that here it will be changed. So what it will be like if I do action A to the actuators, now few things will change here. So there the utility will be added here because the whole thing is now utility based. How happy I will be in such state. So it will add one more state. So what is that state? कि ये एक्शन लिया तो कितना खुश हूं मैं, है ना? So one more element is being added there. So what it will be like if I do action A, then if the action A is taken, then how happy I will be in such state. That is nothing but utility. and based on that, what action I should do now. So there will be one utility element added there in case of goal driven agent, right? Same thing, same figure is there, same thing is there. The working also very much similar to that, but only one thing is added here is the utility based agent will have this utility element in case of goal driven agent, right? So now goals alone are not enough to generate high quality behavior in most of the environment. अब वो बता रहा है कि गोल ड्रिवन एजेंट की सबसे बड़ी प्रॉब्लम क्या थी कि वो लेस एफिशिएंट था, है ना, भले ही वो फ्लेक्सिबल था। लेकिन एक और चीज आप बता रहा है कि भाई सिर्फ गोल बेस्ड काम नहीं हो सकता है ना। अगर आपको हाई क्वालिटी बिहेवियर एक्शंस लेने हैं तो गोल बेस्ड काम करके मतलब नहीं है, आपको कुछ और चीज भी लगेगी साथ में। तो वो क्या लगेगी? फॉर एग्जाम्पल मैं ऐसे बोलूंगा कि कार में मैं बैठा हूं एंड कार इज गोइंग, it is taking left, it is taking right, then it is going to the straight, taking on straight. Now the driver is asking me, what is your destination, what is your goal? So I said that my goal is to reach to Pandharpur. I'm in Aurangabad. Now from Aurangabad there are a lot of turns and twists and everything is going on, very complex path is there. Now what is happening is that I am reaching to the goal, I'm reaching to the goal somehow, but in this no driver hasn't asked me my satisfaction, because the goal is been achieving is achieved there, but where is the satisfaction there coming into the picture? So the distinction will be about the utility is utility driven होना चाहिए ना, कि मैं खुश हूं या नहीं ये important है, उस element में add करना जरूरी है कि whether I am happy or not while going to that destination. That is what the utility driven agent will look like. So you can see, for example, many action sequences will get the taxi to its destination, thereby achieving the goal, जैसे मैंने बताया. But some are quicker, safer, more reliable और cheaper than the other. अब फर्क कहाँ आएगा कि कुछ fast जाएगा, कुछ safe रहेगा, कुछ reliable होगा, कुछ cheaper होगा. In that way, goal just provide a crude binary distinction between happy and unhappy state. So obviously goals will be giving you only the binary distinction whether I'm happy or unhappy state. Is it right? A more general performance measure should allow a comparison of different world state according to exactly how happy they would make the agent. Right? So जाना वहां तक ठीक है, लेकिन बीच में जो डिस्टिंक्शन आने वाला है वो भी तो होना जरूरी है कि ये फास्ट गया, ये सेफ जोन में गया, ये रिलायबल था, ये सस्ता था, अकॉर्डिंगली. Right? So how happy they would be would make the agent will also be very important, because happy does not sound very scientific. Economists and computer scientists use the term utility instead. So utility is what, whether I am happy or not to reach to the destination. So by happy बोलना तो ठीक नहीं लग रहा है आर्टिफिशियल इंटेलिजेंस में, whether I am happy or unhappy, है ना. तो फिर बेस्ट पे उन्होंने क्या निकाला कि चलो somewhat word use करते हैं utility. So they used a utility word for the unhappiness or the happiness of the agent while driving towards a destination. And that's what the utility driven agent is about. The agent's utility function is essentially an internalization of the performance measure. Obviously, the measurement of the performance will come into the picture, and that will be based on the utility agent's utility function. If the internal utility function and the external performance measures are in agreement, then the agent that chooses actions to maximize its utility will be rational according to the external performance measure. सीधी सी बात है कि अगर मैं हैप्पी तभी होऊंगा जब मुझे लगेगा कि मेरा डेस्टिनेशन पहुंचूंगा मैं, लेकिन हैप्पीली पहुंचूंगा, और बिल्कुल ड्राइवर जो है वो उसी तरह से मुझे हैप्पीली पहुंचा रहा है. तो इसका मतलब क्या हो गया कि एक्सटर्नल परफॉर्मेंस मेजर है ना और मेरा इंटरनल यूटिलिटी फंक्शन, ये दोनों के बीच में एग्रीमेंट हो गया है कि भाई आप अच्छी तरह से गाड़ी चलाओ तब मैं खुश रहूंगा और हम लोग गोल्स पे इजीली पहुंच जाएंगे. अगर ऐसा होगा यानी इंटरनल यूटिलिटी फंक्शन plus external performance measure, they will coincidentally act together, will have an agreement and act together that will help to maximize its utility. And that's what it says about. So this utility driven agent is completely based upon the state of mind of that agent, state of that agent. Is it okay? A utility based agent has many advantages in terms of flexibility and learning. So it will learn, it will be flexible. Furthermore, in two kinds of cases, goals are inadequate, but a utility based agent can still make rational decisions. हो सकता है कि two kinds of cases हो जिसमें goal एक बार adequate हो, but a utility based agent can still make a rational decisions. हो सकता है वो inadequate हो, लेकिन फिर भी वो rational decisions की तरफ जा सकता है. So goal adequate, inadequate अगर रहा तो भी वो decisions ले सकता है. First, when there is a conflicting goals, only some of which can be achieved. For example, speed and safety, the utility function specifies the appropriate trade-off. So when there are conflicting goals, only some of which can be achieved, then utility function specifies the appropriate trade-off. यानी कि अगर ड्राइवर मुझे बोलता है कि ये रास्ते से चलते हैं और मैं बोलता हूं नहीं नहीं ये रास्ते से चलना है, तो कहीं तो एक बीच में ट्रेड ऑफ निकालना भी जरूरी है. अदरवाइज क्या हो जाएगा कि गोल पे पहुंचने के लिए उनके बीच में कॉन्फ्लिक्ट होगा. सो कॉन्फ्लिक्टिंग गोल्स नहीं होना चाहिए. उस वक्त यूटिलिटी फंक्शन क्या करेगा कि एक अप्रोप्रिएट ट्रेड ऑफ निकालेगा. इज इट राइट? दैट इज व्हाट इट सेज. सेकंड थिंग इज दैट when there are several goals, that agent can aim for, none of which can be achieved with certainty, utility provides a way in which likelihood of the section can be weighed against the importance of the goal. दूसरी बात यह है कि एक डेस्टिनेशन नहीं है, एक गोल नहीं है, दो तीन गोल है. सपोज इफ आई वांट टू गो टू पंढरपुर आल्सो एंड देन आई हैव टू गो टू पूना आल्सो. अब इस वक्त वो कैसे तय करेगा कि किधर जाना है, कैसे जाना है? दोनों तरफ तो जाना है. सो बेस्ड अपॉन द इंपॉर्टेंस ऑफ द गोल एंड द चांसेस ऑफ लाइकलीहुड, है ना, कि भाई ये अचीव हो सकता है, and that is more important. So accordingly it will take the decision. देखो ना, there are several goals that agent can aim for, none of which can be achieved with certainty, है ना, none of which can be achieved with certainty. दोनों भी गारंटी नहीं कि वो पहुंच सकते हैं. तो यूटिलिटी प्रोवाइड्स अ वे इन विच लाइकलीहुड ऑफ द सक्सेस कैन बी वेटेड. तो सक्सेस मिल सकता है डिपेंडिंग अपॉन द इंपॉर्टेंस ऑफ द गोल, कि भाई यहां मेरा जाना जरूरी है तो पहले उसको इंपॉर्टेंस दो और तभी पहुंच पाएंगे. सो दिस इज हाउ द यूटिलिटी ड्रिवन वर्क्स. Technically speaking, a rational utility based agent chooses the action that maximizes the expected utility of the action's outcome. That is, utility agent accepts to derive on an average given the probability and utilities of each outcome. So obviously वो डेस्टिनेशन तक पहुंचने वाला है, बराबर, डेस्टिनेशन इतने दूर है, उसकी प्रोबेबिलिटी क्या है, हाउ इट विल बी डिराइव, and then accordingly the utilities of each outcome is studied, and then accordingly the decision is taken. In utility based agent programs, we design decision making agents that must handle the uncertainty inherent in stochastic or partially observable environments. Now what happens is that every time there is a certain things that will be there and you can reach to the destination, लेकिन सडनली अनसर्टन चीज अगर होने लग गई तो बीच में, जैसे मैंने बताया कि इफ माय टैक्सी इज गोइंग ऑन एंड आई से दैट इट शुड गो विद द स्पीड ऑफ 100 kilometers per hour. Now everything is planned accordingly. The taxi is going, I am sitting there, the destination is also locked, everything is perfect. Now suddenly rain comes, suddenly there arrives rain, there comes rain, and now what is happening is that the speed I was going through was of 100. Suddenly I have to drop it down to 80, the speed. So how the things is that when it was certain, everything was planned accordingly. Now there is uncertain because of rain has come. So uncertainty तो change के हिसाब से आपको ऑब्जर्वेशंस करना पड़ेगा और उस हिसाब से चेंज होना पड़ेगा, तो डिसीजन मेकिंग विल चेंज अकॉर्डिंगली। सो उसको हैंडल करते आना चाहिए, और यूटिलिटी ड्रिवन एजेंट हैंडल करने की कोशिश करता है ना, यही बोल रहा है वो भी। डिजाइन डिसीजन मेकिंग एजेंट्स दैट मस्ट हैंडल द अनसर्टेनिटी इनहेरेंट इन स्टोकेस्टिक और पार्शियली ऑब्जर्वेबल एनवायरनमेंट। अभी जो बारिश हो रही है वो एक्चुअली क्या है, इट्स एन स्टोकेस्टिक और पार्शियली ऑब्जर्व किया है मैंने एनवायरनमेंट से कि देयर इज रेन आउटसाइड। So now accordingly, this partial observation, I'm taking the decision that the speed has to be reduced. So it should be taken, the decision has to be taken, right? It is true that agents would be intelligent, but it's not simple. लगता तो है कि agent intelligent हो, लेकिन उतना आसान नहीं है। A utility based agent has to model and keep track of its environment, tasks that have involved in a great deal of research or perceptions, representations, reasoning, and learning. So it is not as that easy as it looks like, because as agent can is it should be a simple, but it should be an intelligent. And to be an intelligent, it's not that easy. Why? Because to have an intelligence, you should be having some kind of model. You should be able to keep a track of environment. You should be able to keep a track of the task, है ना? You should be able to represent. You should be able to have good reasoning, and then also learning. All these things comes into the intelligence. So if you want to be intelligent, all these things you have to follow it regularly. Choosing the utility maximizing course of action is also a difficult task. Now he's saying that in order to work on utility based course of action, it is also a difficult task, because it requires igneous algorithms that fill several more chapters. Obviously there will be some kind of certainty, there will be some kind of uncertainty, there will be changes in the external environment, everything will change. So your algorithm should be igneous algorithm that will move, that can move, or that can fill with several more chapters. It is not about only taking action only for that particular situation. That is not possible. The situation may change, then what? So based on different situations, it should have different way of working. So the algorithm should be igneous. It should be working in such a way that it should be able to take or react or response to the changes that has been happening around. Even with these algorithms, perfect rationality is usually unachievable in practice because of the computational complexity. इतना सब होने के बाद भी perfect rationality मिलना मुश्किल है, क्योंकि computational complexity बहुत ज़्यादा है, right? So this is all about utility driven agent. Now we have only one agent that is remaining, and learning agent. So next time we'll finish it, and then we'll have the revision, and this unit chapter, this will be finished. Okay, so we'll stop here.